Having high availability and fault tolerance isn't just a nice feature to have, it's expected and required in many network environments today. So in this nugget, I'd like to share with you some options that we have for high availability with DHCP and then walk you through the configurations to implement them. Let's begin. In the world of networks and systems, a big emphasis is put on HA, referring to high availability, so that the system or the network can be used when it's needed. And one of the common methods to help make sure we have high availability is to have two of things. For example, instead of just having one router, we could have two. In case one fails, the other one could keep going. Or in the case of firewalls, having two of them in case one fails. And that concept is referred to as failover, meaning that if one of our systems or devices fails, the other one can take over. And in the world of failover, it also generally implies that we have some intelligent communication happening between the failover pair, the two devices that are working in conjunction with each other to provide the overall service. And the same is true for DHCP failover. If we have two DHCP servers like DC-NUG and server 2, we can actually configure them as a failover pair to work together. So that implies some type of ongoing chit-chat or communication between the two. It also implies replication. So if we have a scope, let's call it scope 4. And by the way, while we bring up 4, the replication currently is only supported for IPv4. It's not supported for IPv6. But if scope 4 was the scope that we wanted to support with failover, as activity happens to that scope, for example, let's say a client gets an IP address and that's now stored as a leased address as part of the scope, that information is replicated between the two DHCP servers with the intent that if one server went completely out of the picture, the other one could go ahead and be aware of everything and continue offering the services of DHCP because it has an awareness that, first of all, it lost connectivity with the other server and or believes that it is completely gone. So as we configure DHCP failover on our servers, we have two major options. And they are, should we set it up with load sharing, where each one of these servers is going to be actively handing out IP addresses all the time. And maybe we set it up as a 50-50 split. Or if we have one server that's really beefy and powerful, maybe we make it a 70-30 split. And that type of DHCP failover between the two servers, referred to as load sharing, is also sometimes referred to, generally speaking, as active-active failover, where both devices are actively participating and doing the work of that service. Now, another option that we can choose when we do DHCP failover is an option called hot standby. And the concept of hot standby is that one of the servers, let's go ahead and pick on DC-NUG, will do all the work. And then the other server, acting as a standby, will basically just hang out and keep track of the primary device. And if the primary device is no longer reachable, or if the standby device believes the primary has failed, it can then go ahead and take over the responsibility of handing out IP addresses and the renewals and everything else. And that configuration, this hot standby configuration, is often referred to as active standby, meaning one of the devices in the pair is active all the time and the other one is simply acting as a standby, waiting for the active to fail so he can take his turn in the sun and actually do some meaningful work. So regardless of which option we choose, load sharing or hot standby, there's going to be some replication that happens of the events that are going on between the two DHCP servers. And one of the questions that's likely to come up or that someone may ask us is this: is it possible just to do DHCP failover like on one scope or on two scopes, or do we have to do it on all scopes? And the answer is it's on a scope by scope basis. So we could have, for example, DC-NUG. If we're doing hot standby, we could have DC-NUG be the primary device for scope A and have server 2 be the standby device for scope A. Well, at the same time, we could have server 2 be the active primary device for scope Z, for example, and allow DC-NUG to be the standby DHCP server for scope Z. So it's a scope by scope basis. Or if we decided that we want to go ahead and have DC-NUG and server 2 configured in load sharing, we could have them both active for both of those scopes. And if we wanted to split it 50-50 with the load sharing version of DHCP failover, that's what would happen. So in the lab environment, let's do this. Let's create a scope for the 10.3.3 network. And for 10.3.3, let's go ahead and use active-active load sharing, where DC-NUG and server 2 get 50% of the load each for that scope. And then let's create yet another scope for 10.4.4 And let's set that one up as hot standby. And what we'll do is we'll go ahead and have DC NUG be the primary for that second scope, and we'll have server 2 be the standby unit for that second scope. And with those plans in place, my friend, let's go to the lab. So we're going to start on DC-NUG. Both DC-NUG and server 2 both have the DHCP server role installed on them. So here on DC-NUG, let's launch Server Manager by using the icon on the taskbar. And here on DC-NUG, let's go ahead and click on DHCP on the left. And then from the list of servers, we'll right-click on DC-NUG, and from the drop-down, select DHCP Manager. Also, because we're going to want to be seeing what's happening over on server 2 as well, let's add server 2 to the mix here by right-clicking on DHCP, and from the drop-down, clicking on Manage Authorized Servers, and then selecting server 2 from that list and clicking OK. So there we've got DC-NUG and server 2. So if we expand DC-NUG and expand IPv4, there's a lot of the cool work we've been doing so far in these nuggets. And if we expand server 2 and expand the IPv4 section there, we can see the one single scope that server 2 currently has. So focusing our attention on DC-NUG, let's go ahead and right-click on the IPv4 beneath DC-NUG, and from the drop-down, we'll select New Scope. It welcomes us to the wizard. We'll click on Next. And let's name this Active Load Sharing Scope, because once we're done with the configuration of the failover, we'll have both DC-NUG and server 2 as failover partners supporting the scope. And we'll click on Next to continue with the wizard. Next, it wants the range of addresses. And based on our plan, we're going to use 10.3.3. And let's start with .2 in the range, and we'll have .1 be a default gateway. And that way, by avoiding it here, we don't have to exclude it later. We'll hit Tab, and the ending address is going to be 10.3.3.254, which is the last valid IP address if we use a 24-bit mask, which we are going to do. So the length of the network will be a 24-bit mask, and we'll click on Next to continue. It's asking about exclusions. We don't need any. We'll click on Next, and we'll leave the default lease of 8 days is great. We'll click on Next. The radio button for Yes, I want to configure options now is selected, so we'll click on Next, and we'll supply the option for a default gateway. And it'll be 10.3.3.1. We'll click on Add to add that to the list, and we'll click on Next to continue. The DNS server of .100 and the DNS name of nuggetlab.com is fine. We'll click on Next, and we don't need a WinServer, so we'll leave that blank and click on Next. It's asking us if we want to activate the scope, and I'll go ahead and say yes. That'll save us a click later. And then we'll click on Finish to go ahead and close the wizard. So great, now we've got the scope for the 10.3.3 network. Now to start the wizard to configure the failover for the scope, we can either right-click on this scope and from the drop-down say Configure Failover, and that would lead us to Configure Failover just for that scope, or we could go ahead and do it at the IPv4 level. We could right-click on IPv4, and then from that drop-down on IPv4, we could click on Configure Failover. And the big difference is, if we do it at the IPv4 level, it gives us a bigger pick list regarding the scopes that we can choose to replicate. So if you have like 20 scopes, instead of doing them one by one, you could do it at the IPv4 level and then pick them all. So for this demonstration, I'm going to remove this little check from the Select All checkbox. And we want to do failover for just the 10.3.3 scope at this time. So with 10.3.3 highlighted all by itself, we'll go ahead and click on Next. Now it's asking, okay, says DC-NUG, who's the partner? Who am I going to replicate with? And so we'll click on Add Server. Then we'll click on the radio button next to Authorize DHCP Servers, and we'll select Server 2 right here. And with Server 2 selected, we'll click on OK. Now you'll notice we have a little checkbox here, but it's not available. It's grayed out. And that's because we have not configured previously any DHCP failover between DC-NUG and Server 2. If we had, we'd have the option of using the same failover settings for this new scope that we're doing failover for. So with the partner server's name there, we'll click on Next to continue. On the Create a New Failover Relationship page, it puts in the relationship name for us, which is the two servers' names. It has the two modes. The default one is load balance, but there's also, if we use the drop-down, hot standby. So for this 10.3.3 scope, we're going to choose load balance. Regarding load balance, it's going to go ahead and do a 50-50 active-active split. And as they communicate and replicate information back and forth to each other, we can use message authentication just to verify we're not getting messages and accepting messages from a rogue DHCP server. So along with enable message authentication, we'd use a shared secret as part of that algorithm. So what we'll do is for shared secret, we'll put our lab password in. And we have a state switch interval option, which is off by default. If we enable that, the interval would be 60 minutes. And here's how that could help us. If we have the two servers that are talking to each other, so DCNUG and server 2, if all of a sudden, let's say DCNUG dies, and server 2 no longer sees messages from DCNUG, is DCNUG really down, or is there a network failure? So what's going to happen is the actual relationship between the two goes into something called an interrupted state. And if we have this check selected for state switchover interval after 60 minutes of an interrupted state, after 60 minutes of the interrupted state, it'll transfer to partner down. And in a hot standby environment, if the primary is considered to be down, the standby is going to go ahead and fully accept all the discover messages and take responsibility for the whole scope. And even if we don't have the state switchover interval set, there's also a value here, the MCLT, the maximum client lead time, which by default is also set for 1 hour. And that also is going to identify how long a secondary server should sit there and wait before it takes responsibility for a scope. Again, presuming that we're in a hot standby and the primary system is no longer available. So we're accepting all the defaults with the exception of we're adding the password, the lab password for the shared secret. We'll go ahead and click on Next. It gives us a summary. We'll click on Finish, and it just configured the failover for us. And we'll click on Close. So as we look down at server 2, if we don't see that scope, the 10.3.3 scope in the GUI, it's very likely we have to refresh. So click on server 2, right click, and from the drop down select Refresh. And then if you expand IPv4, now we see 10.3.3. And now this DHCP failover pair that are doing load sharing, anything we do on one of them, for example, we make a new reservation or a new client comes in and gets an IP address, that information is dynamically replicated between those two servers. So if one of those servers goes down, the other server has all the information. As an example, here on server 2, if we go to reservations for server 2, at the moment there aren't any, if we right click and from the drop down select new reservation, let's create one. We'll create one called test in active scope. We'll give it the IP address of 10.3.3.50. And for the MAC address, let's make up a MAC address of 112233445566. And we'll click on add. And poof, we now have a reservation. And what will happen is that reservation, just like a lease that was given to a client, will be replicated over to DC-NUG. And if we don't want to wait, what we could do is we could right click on that scope. And from the drop down, there's an option called replicate scope, which will force the replication right now. So we'll click on replicate scope. It provides a summary of what just happened. We'll click on close. And now if we go up to DC-NUG, and let me highlight the server and click on refresh, and we go to that same scope, the 10.3.3 scope, and we go under reservations, there's our reservation. Because all that lease information, including reservations, are being replicated between the two servers, because they're pairs in a load sharing active-active DHCP failover configuration. So next, let's do DHCP failover again for a different scope, but let's use hot standby as the option instead of load sharing. So to do that, let's go ahead and click on IPv4 directly under DC-NUG, then right click on IPv4 and select new scope. We'll click on next, and we'll give this the name of the hot standby scope, and click on next. And for the range, let's use the 10.4.4 network, with the first address being .2, and for the last address, we use 10.4.4.254. And we'll give that a 24-bit mask as well for the length of the mask. And we'll click on next. We don't need an exclusion, so we'll click on next. The 8-day lease is great, we'll click on next. And we'll say yes to the options, and let's give the option of 10.4.4.1 for the default gateway. Click on add, click on next. For the domain name and the DNS servers, we'll accept nuggetlab.com and the IP address of DC-NUG for the DNS server, and click on next. We don't need a WinServer, so we'll leave that blank. Click on next, and then we'll click on finish. Great, so let me go ahead and refresh all of that on DC-NUG. So here's the 10.4.4 scope. With it selected, if we right click just on that scope and go to configure failover, you'll notice because we started at the scope level, it's only going to offer us that one scope of 10.4.4. So we'll click on next to continue. Here we'll click on add server. We'll go ahead and use the radio button regarding authorized servers. We'll select server 2 as our DHCP failover buddy. Click OK. And you'll notice that now we have this box with a check in it, and this option is available. Meaning, if we just use all the existing settings, we're done. However, previously, we did load sharing. And for this demonstration, for this scope, we want to use hot standby. So let's remove the check from that checkbox and click on next. So regarding the mode, from the drop down here, we'll select hot standby. It's asking us from the scope of addresses, what percentage do you want to just kind of keep in reserve for the standby unit in the event that he needs to go ahead and start handing out addresses. So the default is 5%. We'll leave it at that. I'm also going to enable the state switchover interval. So if there's interrupted communications for more than 60 minutes, the standby unit is going to assume that the primary is down and will take over for the scope. And we'll supply the password for the message authentication. And with that supplied, we'll click on Next. It's giving us a summary. We'll click on Finish. It did the configuration. Everything was successful. And we'll click on Close. So now for this hot standby group, all the work for 10.4.4 for that scope is going to be handled by DC-NUG, the primary. And if DC-NUG goes down and goes missing for like an hour, and server 2 has not been getting messages from DC-NUG, server 2 is going to go ahead and say, well, my partner's down. I'm going to take ownership and be responsible for that scope. And to do that, server 2 needs to know what's going on with that scope. So just like with load sharing, where both systems were active and there was replication of the events that were happening regarding that scope, with hot standby, we're also going to have that replication of the events that are occurring, including the leases. So on the primary scope here on DC-NUG for 10.4.4, if we went to reservations and we right-clicked and said new reservation, and let's call the reservation name test for hot standby, we'll give the IP address of 66, and the MAC address we'll use 221133445566. And if it's not the right number of digits, it will tell us, and we'll click on add. Then we'll click on close. And now we have that reservation. And in a little bit of time, that'll be replicated over to server 2. With hot standby, if we don't want to wait for the replication, we can right-click on the scope and then select replicate scope. And it'll do it for us. Or if we want to do all the scopes at once and replicate everything that we have load balancing set up for, we could go up to IPv4, right-click. And from the drop-down, we can select replicate failover scopes. And we get a warning saying, whoa, we're going to do all your scopes that currently have failover. This may take a while. In our lab, we only have 2 that are doing failover. So we'll click on OK, and it replicated both scopes. So now if we click on Close, and we go over to Server 2, I'm going to click on Server 2 and click on Refresh to refresh that, and go under IPv4 and open up the hot standby scope and go to Reservations. And it's here on Server 2 because of the replication that's happening between the pair of servers with DHCP failover. And now, my friend, it is your turn. I encourage you to practice this in the hands-on labs that we've provided so you can get that practice configuring both load sharing and hot standby options for DHCP failover. And I look forward to seeing you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.